Hello students, ICSE batch 2021. Dear students, today we are going to perform experiment based on light. So first, let's know about light. What is light? Light is an invisible form of energy which causes in us the sensation of vision or sight. Dear students, light has got many phenomena under which we are going to perform refraction of light. So let's know about what is refraction of light. Refraction of light means when the ray of light is traveling from one optical medium to another optical medium, the ray of light will get bent either towards the normal or away from the normal. It depends whether the light is traveling from rarer medium to denser medium or denser medium to rarer medium. There are two laws of refraction of light. One is incident ray, refracted ray and the normal all lie at the same point of incidence on the same plane of incidence. Number 2 was given by Willibald Snell. Snell states that when the ray of light is traveling from one optical medium to another optical medium, for a given pair of media and for the given color of light used, the ratio of sine of angle of incidence to the sine of angle of refraction bears a constant ratio, and that constant ratio is known as the refractive index of the second medium with respect to first medium. Now dear students, we are going to perform experiment to find the refractive index of a rectangular glass block by geometrical construction. Now dear students, the apparatus required to perform the experiment are a rectangular glass block, a white sheet of paper, drawing board, drawing pens, ruler, protractor, pencil and compass. As we have already done about the refractive index, right? Now dear students, in theory part you can see in triangle DOF, that means right angle triangle DOF, this will be your perpendicular, that means this is 90 degree, that means side opposite to 90 degrees hypotenuse. Similarly, we have drawn one perpendicular GE on refracted ray OT, right. So here GE is perpendicular, OE is hypotenuse. Now if you see right angle triangle DOF, we get sin I, that means sine of angle of incidence, is equal to perpendicular divided by hypotenuse. So perpendicular is DF and hypotenuse is OD, right. Similarly, in right angle triangle GOE, that is GOE, here also angle EGO is 90 degree, that means OE is hypotenuse, GE is perpendicular if you are taking R as the acute angle. Here you can see sine of angle of refraction is equal to perpendicular divided by hypotenuse. So here perpendicular is EG and the hypotenuse is OE, right. So refractive index of glass with respect to air, this kind of refractive index is known as absolute refractive index of glass, is equal to sine of angle of incidence by sine of angle of refraction, which was given by Willibald Snell, which is equal to, from trigonometrical ratio we have DF over OD divided by EG over OE. Now if you change the sign, this division sign into sign of multiplication, this will get reciprocal. Again this OD and OE are the radii of a circle, because we have to draw a circle here. So radii of the circle are same or constant, so you can cancel these two. So ultimately we are getting refractive index of glass is equal to DF divided by EG. Now we will move on to experimental part. So the apparatus required are rectangle glass block, this is your drawing board, this is drawing pin, this is your white sheet of paper, pencil, protector, compass and ruler. Okay. Okay, dear students, as I have already performed this experiment, now I am going to show you how I have performed this experiment. So, at first what I did is I placed the glass slab on white sheet of paper over the drawing board. After that, I have drawn the boundary of the glass slab. Now, we can remove the glass slab. After that, we can take the measure of upper face of the glass slab. As I have got here 10 centimeter. So, middle of the 10 centimeter is 5 centimeter. I put up mark at 5 centimeter mark, and with the help of ruler I have drawn a normal passing through the point O. So, this point O is known as point of incidence. After that I place the protector at O. So, that means at the interface it is showing 90 degree. That means this normal is perpendicular to the interface. Interface means face separating two media, that is above the face we have got air and below this face we have got what? Glass slab, and we are finding the refractive index of glass slab with respect to air. Okay. Now, we can see here. So, if you arrange like this, we are going to perform experiment for 10 degree. So, I have arranged this at 10 degree here. Now, this is 0, this is 10. So, after setting at 10 degree, I have drawn a line, that is incident ray with the help of ruler. So, I have joined the line AO. With the help of drawing pin, I have put two drawing pins at point A and point B on the incident ray. After that, I have replaced the glass slab on the original position. Now, from the other side of the glass slab, I am arranging the pin in such a way so that all the pins must lie on a straight line if we view from the other side of the glass slab. Dear students, if you see from the top, these two pins are not lying on the same line with these two pins, right? Do you know why? Because here all the pins are lying in air and our eyes are also in air. So here refraction of light is not taking place. Why? Because the speed of light is constant in air. Now dear students, if you see through the glass slab, all the pins are lying on a same straight line, right? That means this line, right, as the ray of light is passing through the glass slab, this ray of light is known as the emergent ray, right? So on the emergent ray, I have arranged two pins. Dear students, this BC is known as emergent ray, right? So that means these two pins are lying on the emergent ray. Now, if you remove this glass slab and see, this angle of incidence will be equal to angle of emergent theoretically, but practically there will be little bit error will be there. Now, again with the help of scale, if first we can remove all these pins and circle them. Now with the help of scale or ruler, if you draw or if you produce the incident ray, it can move forward, but it is not lying with the emergent ray. That means some constant difference they are maintaining. So this constant difference, perpendicular distance, is known as the lateral shift or lateral displacement. Now our aim is to find the refractive index of glass with respect to air. So for that, for geometrical construction, what I am doing is, with the help of compass, I have drawn a circle measuring 4 centimeter, and this circle cuts the 2 points at D and E. That means this D is a point on the incident ray and this E is a point on the refracted ray. With the help of scale, if you draw a perpendicular, right, perpendicular, that is DF. That means if you are drawing a perpendicular from D onto the normal at F, then this will become your 90 degree. Similarly, we can draw a normal or perpendicular on the normal at G. So that means EG is perpendicular, right? Similarly, DF is perpendicular. Dear students, now with the help of ruler, you can measure this perpendicular distance, right? So DF is coming 0.8 centimeter and GE, or we can say EG, is coming 0.5 centimeter. So if you are using this in the relation, mu is equal to DF by EG, will get 0.8 divided by 0.5. So since you can write centimeter, centimeter, centimeter and centimeter will get cancelled, so mu is equal to 1.6, right? So there is no unit for refractive index. Why? Because it is the ratio of two similar physical quantity distance. Similarly, I have performed the experiment for 20 degree. So in 20 degree, the observations I have got are DF equal to 1.6 centimeter. I perform the same experiment, same procedure is there. DF equal to 1.6 centimeter, GE is equal to 1.0 centimeter. So the value of mu is coming, mu equal to DF over EG, which is equal to 1.6 divided by 1.0, which will give you 1.6. That means for second observation also I have got mu is equal to 1.6. Now for third observation, that is for 30 degree, I have got DF equal to 2 centimeter, GE or EG equal to 1.3 centimeter. So mu G means this is the absolute refractive index of glass is equal to df divided by Eg, which is equal to 2 centimeter divided by 1.3 centimeter. Centimeter will get cancelled. If you divide this 2 by 1.3, we will get mu is equal to 1.538. If you round this off up to 2 places of decimal, we will get 1.54. Now, for fourth observation, that is when the angle of incidence is 40 degree. We have got df equal to 2.5 centimeter, Eg equal to 1.6 centimeter. So, the value of mu, that is refractive index of glass, we are getting mu g is equal to df divided by Eg, which is equal to 2.5 divided by 1.6. If you divide this 2.5 by 1.6, we will get mu equal to 1.562. If you round it up to 2 places of decimal, we will get 1.56. Now, I am taking out the fifth observation, which I have drawn on the back of this. Now, for fifth observation, that is for angle of incidence 50 degree, I have got df is equal to 3 centimeter, Eg equal to 2 centimeter. So, if you substitute in the above relation, mu equal to df divided by Eg, which is equal to 3 centimeter divided by 2 centimeter. If you divide this 3 centimeter and centimeter will get cancelled. If you divide this 3 by 2, we will get mu equal to 1.50. Now, I am going to show the values of these experiments on the blackboard. For 10 degree, angle of refraction is 6 degree, df I have got 0.8 centimeter, Eg is equal to 0.5 centimeter. If you divide, you will get 1.6. For angle of incidence 20 degree, angle of refraction I have got is 12 degree, df equal to 1.6 centimeter, Eg is equal to 1.0. If you divide, you will get 1.6. So, these are the observations of the 5 experiment. Now, as we have performed 5 experiment, so we must find the average value for mu, right. So, for that what we can do, mu g is equal to, first value we have got 1.6 plus 1.6 plus 1.54. For fourth observation we have got 1.56. For fifth observation we have got 1.50. Divided by number of observation is 5. So, if we add this all, we will get 7.8 divided by 5, which is equal to 1.56. So, the average value for refractive index of glass is, experimentally we have got 1.56. So, dear students, I hope all of you have understood this. Now, you can see from the table, as the angle of incidence is increasing, angle of refraction is also increasing. Similarly, we can see the perpendicular distances are also increasing accordingly, but the average value for mu g is coming 1.56. Now, just tell me, what do you mean by refractive index? Number 1. Number 2, does the refractive index depends upon the wavelength of light or not? Number 3, does the refractive index depends upon frequency of light or not?